Three supporting cables exert the forces shown on the side. Represent each force as a Cartesian vector. So the question is asking us the three supporting cables. So we are having this cable AC, cable AB, and cable DE. The three supporting cables exert the forces shown on the side. Represent each force as a Cartesian vector. So we have on cable AC, FC is equal to 400 Newton. On cable AB we have FB is equal to, again, 400 Newton. And on cable DE we have FE, which is equal to 350 newtons. Right. First of all, we need to write position vectors for each. So position vector for AC, RC, will be equal to, so this point here is the origin for the X, Y, and Z axis system. So the coordinates of A and C, based on these coordinates, we're going to be having for RC 0 minus 5I plus minus 2 minus 0J plus 3 minus 0K, and which will be expressed as minus 5I minus 2J and plus 3K, and the unit is, of course, meters. So this is the vector RC, and the magnitude or the length of this vector, which is essentially the length of cable AC, will be minus 5 squared plus minus 2 squared plus 3 squared and square root. So that is equal to square root of 38. So that's meter. So we repeat the same operation for RB, and for RB, which is cable AB, we're going to be having for vector RB 0 minus 5I plus 2 minus 0J and plus 3 minus 0K, and which will be minus 5I plus 2J and plus 3K. And the magnitude will be minus 5 squared plus 2 squared plus 3 squared and square root, and that is also equal to 38, square root of 38 meters. You may notice that there is a perfect symmetry around the x-axis. Okay, so we continue with writing vector RE for our cable DE. Okay, so the coordinates for point D, and coordinates for point E. Based on these coordinates, we're going to be writing our RE vector So that will be equal to 0 minus 2i plus 0 minus 0j, because y coordinates for both is 0, and for the z coordinates we have 3 for point E and 0 for point D, and that's k. So the RE vector will be minus 2i plus 0j and plus 3k, and the magnitude of this vector will be minus 2 squared plus 0 squared plus 3 squared and square root, and that will be equal to square root of 13 meters. Okay, so these are the position vectors. So we know that we can write force vector by multiplying the magnitude with a corresponding unit vector, and this unit vector can be written as a position vector directed along the force and its magnitude. So that's the u vector. So this is how we are writing the unit vector. So that's the unit vector. Okay, so we're going to use this formula or equation for writing FC, FB, and FE in Cartesian as a Cartesian force vector. So our FC vector will be the magnitude of the FC vector, which is 400. Okay, so FC vector will be 400 times the RC vector is 5i minus 5i minus 2j plus 3k over square root of 38, and this is equal to minus 324i minus 130j and plus 195k, and that's Newton. For force vector FB, so we're talking about the force along this cable, so force AB, so force B, the magnitude is 400. So by observation, by symmetry, we can quickly write, but we're going to be careful about the signs here. And so RB is a bit different than RC due to the J coordinate 5i. So this was minus 2j, and on the y-axis point B lies on the positive y-axis, positive side of the y-axis. So it's plus 2j, so 2 meter, minus 2 meter and 2 meter, and plus 3k over 38 meters. So that would be equal to minus 324i plus 130j and plus 95k and Newton. For FE, which represents the force directed along DE, this cable, this is the tensile force developed in this cable. So for that, we have a given magnitude of this force which is equal to 350 newtons. So for that, we're going to be writing 350 times a RE over RE vector over the magnitude of RE. So that would be minus 2I plus 0j plus 3k over square root of 13. And that is equal to minus 194I plus 291k, right? And that's Newton. So this concludes the solution of our problem. Thank you.